Hi all, welcome to the lecture. I am Dr. Serin Simpson. I belongs to Department of Computer Science and Technology. Today we are going to discuss about sorting techniques. Sorting is a non-process. In our day-to-day life, we are using this process. Knowingly or unknowingly, we are applying different aspects or the procedures for doing the sorting. So it's a non-topic, and why we need to discuss more about sorting. I will take you to that point. See, for sorting, it's a simple process like in an ascending or descending order. We need to order the things. That's what we are mean by sorting. And in the case of sorting, how we are making the sorting that may differ. Like I will get you some kind of things how we are doing the sorting process. One approach that we can do is we will be finding the smallest one, and we will be adding one by one, and we'll be reaching to the highest level. So that is one way of approaching to sorting. And other way, suppose you are playing cards. At that time, you'll be getting a few number of cards, and at the beginning itself you will be sorting it in some kind of methodology you'll be applying, and afterwards during the time of that playing, you'll be taking one card, and that card will be added to the exact place. There also you are doing the sorting process, but it's in a different way. You'll be finding a place and you'll be adding the card to the exact place where it should belong. So that's what the second methodology you are applying. And I will take you to one other scenario. At the time when I'm collecting the assignments from students, it will be applicable to all the students, like and around 60 students will be there. During that time, all the students will be submitting the assignments, and they won't come in a single stretch. It may take a 5 days or 6 days process, and during that time, I'll be collecting all the assignments. And next process is after getting all the assignments, I need to sort it. To identify whether anybody is not submitted or not. To ensure that I need to sort it. At that time, it is really difficult. Why? Because it contains almost 60 assignments, or more than 60 assignments, and I need to sort it based on their roll number. So at that time, I'll be applying a new terminology or methodology. I will not finding the lowest roll number, and I will not going in that way. Instead, I'll be making into different sets. Suppose the roll number starts from 1 and it ends at 60. I'll be making into a few sets like 1 to 10, 11 to 20, 21 to 30. In this way, I will go. And whenever I get 1, I'll be adding the to the first set. And whenever I get 21, I'll be adding to another set. So all the tens will be added to different sets. And afterwards, again, I'll be taking each set and I'll be applying some methodology to sort it. And combinedly, I will do that. So now itself, we discussed three methodology that we can apply in the case of sorting. So sorting is a simple process, but it differ based on the methodology. That's why we are discussing about this topic. And I'm taking you to the next slide. Here you can see that we are going to discuss these four topics that we are commonly applying in computer science for sorting mechanisms. The first one is selection sort, and next one is insertion sort, and bubble sort, and merge sort. So these are the four sorting mechanisms that we are going to discuss, and I will let you know how, on what basis it is getting some kind of difference, and how it is being done. Everything I will be teaching you in this lecture. So moving to the first sorting mechanism, that is selection sort. From the name itself, we can derive something. Here in the selection sort, we are selecting something. We can assume in that way, or else we can infer from the name itself. We are selecting what we are selecting. That's what we are going to discuss here. You are able to see a few numbers. That is not in the sorted way. It's in unsorted way where I have arranged in the first leftmost place. Like you can see that 20, 12, 10, 15, and 2. And here first we need to select the first. We have to consider the first element. Now it is 20, and we need to ensure that this 20 is the smallest one. Obviously 20 is not the smallest one, and we need to point towards the smallest one. So we'll be comparing 20 and 12. Yeah, at the time when we are comparing, yeah, in the middle portion you can see that when we are comparing 20 and 12, there you will be identifying like 12 is the smallest one, and again 12 and 10 will be compared, and you will be identifying 10 is the smallest one, and 10 and 15 will be compared. There you won't change the pointer because 10 is the smallest one. Again 10 and 2 will be compared, and you will be identifying 2 is the smallest one. So now you came to a conclusion like 2 is the smallest one, and that 2 will be should be placed at the first because we need to get in the ascending order, and so the smallest one will be placed at the beginning. At the time when you are placing the smallest one at the beginning, that the one which is already present there, that is 20, the 20 will be swapped in between the minimum and the first one. So at the last figure, you can see that 2 and 20 has been placed in this way, like 2 is reached to the first place because 2 is the minimum one. I'm taking you to the next slide. There you can see how we are doing this. In terms of computer science, we will go with iterations, and here the after the first iteration, 2 will be placed at the first place. So that's what we discussed in the previous slide. And moving to the second iteration, there we need to find the second smallest element. So here we will be starting with the second element, like in index ways, we will be starting from the first index because we already done with the first zeroth index. And here in the second step, in the second iteration, we will be starting with the second element, which is 12, and we'll be comparing with all the remaining elements. And once we reach to the 10, we'll be identifying that 10 is the smallest element, and 15 and 20 will be compared, but we will not change the pointer because 10 is the smallest among these four elements, and 10 will be replaced to the second position. There we can see the 12, and 12 and 10 will be swapped, and 10 will be reached to the second point. So this is what happens in the second iteration. And moving towards the third iteration, and in the slide you can see that it's see it as step 2. And in the third iteration, you will be finding the third element. There you can find that 12 is the smallest element, and we don't require any kind of swapping because 50 and 20 is already placed in the other places only, and we need to take 12 to the third position, but 12 is already there in the third position. And moving to the towards the further iteration, but we don't require any kind of changes because 15 and 20 are already there in the exact place. So this is what about the selection sort. We are finding the, or else we can say that we are selecting the smallest element, we are placing at the right place. So this is all about the selection sort. This is one mechanism that we can apply for sorting. And moving towards the next topic, or else next sorting mechanism, that is insertion sort. In the case of insertion sort, it is just like how we are playing the cards. As I told you at the beginning itself, in at the time when we are playing the card, we are employing a new terminology. Like we'll be initially we'll be sorting all the cards. Afterwards, we'll be taking one new card, and the new card will be placed at the exact place we want to get it in the sorted way. So here in the figure itself, you can see that 12 is a new card, and where we can place 12. 12 should be placed after 24 and should be placed before 36. So we'll be making a space in between 24 and 36, and we'll be placing 12 at that point. So this is what we have to do. But when we are comparing this, we can see that 24 is larger than 12, so that is not the exact place, and we will be placing 12 before 24. So 10 in between 10 and 24, we need to place 12. And moving towards the next slide, here you can get it in the right way. We need to find the place, and we need to place the number at the exact place. So for that, we will be making it into two arrays. So initially we'll be having all the elements in the same array, starting from 99, 55. You are able to see 4, 66. These are the numbers in that array. This is an unsorted way, and first we will be considering the first element, and we will be separating it into two arrays. So here you can see in the first array we have only one number, so there is nothing to worry about the place. 99 will be placed at that first position only, and the remaining numbers will be there in the second array. And moving towards the second iteration, we'll be considering the first element in the second array. Here you can see that 55 is the first element, and 55 will be taken to the first array from the second array. And now we have 55 and 99, and we will be able to find the exact place for 55, and that's what we are seeing in that figure. 55 will be placed before 99. And I will be explaining one more iteration. There you can see that next element is 4, and 4 will be taken from the second array, and 4 will be added to the first array, and we need to find the place where we will be adding. Here we will be comparing with all the elements present in that array. 55 and 99 are greater than 4. So obviously we have to place 4 at the beginning. So that's what you are seeing there. And moving towards the next iterations, we'll be considering all the numbers like 66, 28, and whenever we are getting a new number, we'll be placing in the first array at the exact place. And finally, we'll be getting the sorted array in the first sorted array in the first array. So that's what you are seeing at the bottom. 4, 28, 31, 36 in the sorted way, you will be getting the numbers. So this is all about the insertion sort. So we have seen two sorting mechanisms. One is selection sort and other one is insertion sort. I hope you are able to understand the difference between these two sorting mechanisms. I'm taking it towards the next process, that is called bubble sort. And here, this terminology is different. I think with the support of next illustration, you will be able to understand, you will get the clear idea about bubble sort. So I am taking you to the illustration related to bubble sort. So here, the first array you are able to see, right? Here, the numbers are in an unsorted way, starting from 77, 42, 35, it's end with 5. So we are aware how we will be getting the resultant array, and 5 should be placed 5 should be placed at the first place, and 101 will be reaching to the last place. And comparing to the selection sort, in selection sort, what we have done in our example, we found the smallest element, and we were placing the smallest element towards the left of the array. Here in bubble sort, in this illustration, what we are doing is we are trying to find the highest element, and that large element will be placed at the last place in the array. So here you can see that 77 and 42, we kept it in a bubble. And we'll be comparing that, and we will find like 42 is the smallest element, and we will be swapping that. So here we are doing the swapping, not like selection sort. In selection sort, we were doing the swapping only after finding the exact number, or is the smallest element. Here we are we are doing the swapping in each step. So 42 will be swapped and 77 will be moved. And you can see the next figure. Here 42 comes at the first place, and 77 reaches to the second place. And it will go on like this. 77 and 35 will be compared. 35 will be reaching to the second place. 77 will be added to the third place. And 77 and 12 will be compared. Again, the swapping process will be continue. And again, 77, 101 will be compared. Here, there is no need of swapping because it is already there in the sorted way. And finally, 101 and 5, what the numbers which are present in the bubble will be compared, and 5 will be added to the second last place, and 101 is now reaching to the last place. So this is the process related to bubble sort. So we are finding the largest element, and we are adding to the rightmost place. The same thing will move forward in the same way, and we'll be getting the second largest element, and afterwards we'll be getting the next largest element, and we'll be adding towards the right side of the array. So finally, the final output will be the numbers in the sorted way. So this is all about bubble sort. Moving towards the next sorting mechanism, that is merge sort. Here it's a kind of divide and conquer method. We'll be dividing the elements, and we'll be conquering. We are conquering it as a sorted way. So that's what we are doing in merge sort. You can compare this in the way how I've explained at the beginning with an example, like the way how I am collecting the assignments, and the way how I am making it into a sorted way. So in that mechanism, in that example, I explained like I'll be making into different sets, and so the entire assignments will be divided into different sets, and those sets will be merged afterwards. So finally, I will be getting all the assignments in a sorted way. This is the same thing happening here. Here we'll be dividing the entire array into two. Again, we will be doing that the same process, like we will divide into the single element towards reaching to the single element. We'll be going forward, and afterwards we will be merging. At the time of merging, we will be doing the sorting process. So this is this mechanism we can compare with the example which I have given at the beginning, that how I'm applying some methodology to sorting the assignments. So this is all about the merge sort. So these are the four mechanisms that I would like to discuss through this lecture. These all belongs to that sorting techniques, and I hope you could identify the difference between these four mechanisms. That's all about this presentation. Thank you very much.